Hi everyone, welcome to my very first YouTube video. My name is Dre McQueen and I'm the founder of Dragon Consulting. Today I want to talk to you about IT application testing, and in particular 5 of the common categories of testing types that we use in healthcare. So I imagine that most of you, or quite a few of you at least, have been in a situation where there's a change been made to an IT application and something happened that you weren't expecting. And from an analyst perspective, if something happens that you weren't expecting and the end users report that back to you, there's conversations that typically follow, and in those conversations, someone will invariably ask, did we test that? Why we're asking that is because testing is incredibly important in the environment. Not just in healthcare, but in all areas where technology is used. So why is testing important? Why is that question asked? Well, testing is done for a few reasons. First, it's used to find issues with the code or the configuration. So by configuration, I mean the settings that lay on top of the code, the user side. So items in a checklist that you're going to configure to your organization, certain layouts and preferences on the screens, things like that. So it's to find issues with those. It's also to confirm that everything is working as expected. So when certain actions are performed inside of an IT system, you expect a certain thing as an outcome. This is to make sure that that actually happens. You also complete testing to validate that the outcomes meet the requirements. So anytime a system is built or anytime a change is made, there's usually a set of requirements that drives that development. So you're needing to incorporate certain things, or you need certain actions and behaviors to happen. So testing is done to make sure that those are actually incorporated, that what you identified as being needed is actually contained. And last but certainly not least, it is to reduce the risk of unanticipated issues happening for end users. So we don't want anything unexpected to happen in the use of the application. So we want to make sure we test through scenarios so that everything that's going to happen with all of the actions and clicks that are taken are things that are expected, that we can communicate, and that are well understood. So with testing, there's several different types. And a lot of these types will have different names in different organizations, may have titles in different industries, but in general, they're going to follow the same characteristics. So I may have labeled them a little differently than your organization has, but I basically wanted to talk about the categories as an overall to let you know the differences between them and to give you some examples of what I mean by those, and those examples in particular focused on the health industry. So the first one that I want to talk about is unit testing. So this is an initial round of testing or initial round of steps that's completed to make sure that the code and the configuration actually produces the result we want. So we want to make sure that 1 + 1 = 2. And that if we put those things together and have that sequence, that actually is going to be the result. Best practice dictates that this be completed by someone other than the person who set it up, so not by the analyst or the developer that actually made the change or configured the system. And that is so that we can truly understand what it is that we're expecting to happen and what we changed. So the developer or the analysts that made the change will articulate what it is that has changed, what the context and parameters are around that, and what they expect to happen when someone performs certain things. And a second set of eyes will then run through that test script to make sure that does in fact happen. So the extent of the test scripts should correlate directly to the size of the change and the complexity of the application. So if it's something very straightforward, 1 + 1 = 2, then your test script should reflect that. If it is a little bit more complex and there are layers to the change, then your unit testing script should reflect that. So they need to correlate with the size of the changes. So an example of something that we would consider unit testing, or that I would consider unit testing, is the creation of a new lab item. So if a new lab item is added to the catalog or a new pharmacy item to the formulary, we want to make sure when that order is entered or when someone goes to grab it off the browse, that the correct order form opens. So it has the right form attached to it, and that the fields that are on that form present the correct choice options. So at its very core, is the shell of the item and the insides of the item, do they match? Do they align? So that would be an example of unit testing. I'm going to carry this example through a bit more to give you sort of a more comprehensive view of what I mean by the next ones. So the second category that I want to talk about is functional or integrated testing. So functional or integrated testing confirms that the functionality and the technical workflow perform as expected. So does the actual change perform the way we expected it in the context that we expected it to perform in? So this includes testing both within the application that we're talking about, as well as between any other applications that are connected to it. So if the particular change involves other systems, then integrated and functional testing will make sure that that comprehensive sort of workflow is done. It is more comprehensive than unit testing, so it's more all-encompassing. And it doesn't necessarily need to have changes done in both systems if there's connections. So in the example that I'm going to give of the lab item, I don't have to have made the changes in both systems. So if we're going to use that same lab item order that we talked about in the unit testing, in the functional testing, the things that we're going to look for is, does that new item display in the correct location on the browse? So when I look for it, or when I search for the item within my health record, do I find it where I expect to find it? Is the role-based security attached to the item correctly? So if I only want licensed providers to be able to enter that order, is that true? Are they the only ones that can place it? Or, do I unfortunately have a situation where anyone can enter it? That would be a failed defect. So I want to make sure that the role-based security that I've attached is actually functioning. I also want to make sure that the item as I enter it is transmitted appropriately to the lab system or to the other internal lab module. So whether I'm connected to another application or just another section of my own application, I want to make sure that it's actually going across correctly and that everything is working there. I want to make sure that as things change with the item, is it updating appropriately? Does it tell me when a sample's been collected, if that action's been taken? Does it tell me when there's preliminary results back? Does it update when it's finalized? Do the results display correctly? So when result components are attached to the item and entered by the lab analyst, do they actually display the way I expect them to display? Are they connected? Does it say the order is done now? And does it show up the way it's supposed to show up on all of the tabs it needs to be on, or in all of the areas of the application that it needs to be? Does it also go across to reports? So is it included in everything it needs to be included in? This is all part of the functional or integrated testing. The next category that I'd like to discuss is user acceptance testing. So user acceptance testing is fairly robust. It actually confirms that the changes made produce the outcomes that were anticipated by the end users. So up until now, you'll often have your build or development team as well as a quality assurance team performing the testing. And they are a little more skilled and highly focused on the technical IT aspects. You want to make sure user acceptance testing, it's actually the end users. So is it doing what they thought it would do? You're not going to necessarily perform user acceptance testing with every single piece of change, but certainly for things that are complex and with initial implementations, you should run through this to make sure that there isn't sort of a discrepancy between what IT thinks is happening and what end users think is happening. So again, this one is used to validate that the design and the build meet the requirements. So the end users participate, hopefully, in the actual setting up of the requirements, and this is the chance to close the loop with them so they can see before something goes live that their requirements were actually met. In user acceptance testing, or UAT as it's often referred to, users are going to interact with the application in the same way that they would in the production environment. So while the test scripts may have very, very defined steps for them to follow, it's not terribly unusual for them to get a little creative here. So they're going to use the application the way they're used to using the application, which is a good thing. You want to make sure that in their daily work, there isn't anything different about sequencing or about behavior that's going to produce an unanticipated result. You want everything to function as you designed it to function. So it does incorporate timing, and it does also incorporate surrounding functions. So this is a day in the life. So there's other things that are going to interact, and this is what you want to happen. So an example of this is, instead of just looking at the lab item in isolation and following it all the way across, you're going to look at the lab item in the context of a patient attending an outpatient lab for the completion of a few tests. They're going to have multiple things entered, maybe in different ways, sometimes through an order set, sometimes through the browse, maybe as an add-on test by the appropriate provider, and then the results would get looked at. So you'd look at it in that context. Another way that you could try this particular one is you could have a patient present to the emergency department, and the labs were ordered as part of an initial investigation in conjunction with some other things. Again, the provider is going to follow up when the results come back, and you want to make sure that everything associated with the environment that they're being entered in, as well as with the item, is functioning correctly. So the last couple categories that I want to go over are, they've got a little bit of a different focus. So again, they're still looking to see if there's unanticipated things that are going to happen and to make sure everything we've designed is functioning appropriately, but just in a little bit of a different way. So regression testing is something that's done to confirm that there isn't impacts that we weren't expecting, or unknown, unanticipated impacts to areas other than what was changed. So with the huge complexity of the applications that we're using today, there's the connections and intricacies that are really, really difficult to people to be experts in when it comes to the whole entire application. So one of the things that's frequently done, if a change is made, is there's a regression script that's run that is a basic, higher level testing of everything around it. So an example of this is if I've got a hotfix or a patch, security patching, things like that, that I'm going to have a technical resource implement in the application. I want to make sure, even though that's targeted at a very specific spot, and it's meant to only touch a couple things, I want to make sure, in addition to testing what it's supposed to touch, I want to look at, did it impact anything around it? So did it reach in the application, or did it connect to anything I didn't think it would, or that it wasn't supposed to? So people make mistakes, and this isn't something that happens on a frequent basis, but you want to make sure that if you've implemented something, there's not an area around it that's getting negatively impacted. So regression testing will take care of that. It's typically fairly broad, shorter in duration. One of the most common times to use this is after a downtime. So if we've taken an application offline and made some changes to the application and then brought it back up online, one of the last things that the IT team will do before they release it to the end users is they'll run through a regression script to make sure everything is functioning as it's supposed to be functioning, even if it wasn't the target of what we've changed. So this one is very, very important, and is being added in more and more. You do want to make sure that there's a balance between the amount of things you're testing and the time that you're taking to do it. So you don't want to, stay in a downtime longer than you have to, but you also need to make sure that you have a good idea that everything is functioning correctly. So the last and final category that I wanted to mention is load or performance testing. So performance testing is used to confirm or to gauge whether the application is going to actually function with the volume and capacity that it needs to function in the production environment. So frequently test systems are not set up to the full capacity of a production environment or a live environment. And that can be both from a technical perspective, so from a computing processing perspective, as well as from a data perspective. So you often have an enormous amount of data in your production environments, especially in healthcare. And in your testing environments, because you most often do not contain any actual personal health information, they're usually test patients only, you simply don't have the volume and the magnitude in a test environment that you do in production. So you are frequently making sure that the test environment's cleaned, your test patients don't have, the longitudinal encounters over time that you might see in a production environment. So just the magnitude is different. So there are particular changes that happen that you want to make sure that once you put them in a production environment and that capacity and volume needs to change, is it still going to function the way you think it's going to function? And is it still going to behave as you expected it to? Or is something about that going to change? So an example of this would be e-prescribing. So when we go to e-prescribe, we are usually connected to several different systems. We're checking eligibility, we're transmitting to pharmacies, we're doing all of that. And in a test environment, it's a very isolated, simple connection, few messages sent back and forth. Once we get into the production environment, that's going to increase a huge amount. So you're going to have multiple people in the system concurrently, you're going to be transmitting messages back and forth, you're entering into an environment where with something like SureScripts, you've also got a whole bunch of other organizations that are transmitting to them as well. And you want to make sure that the timing and the behavior is still what you want it to be. You don't want it to drastically slow down when you get into the production environment, because even a couple seconds a day is going to have a huge impact on your organization once you multiply that by the volume. So it's important to make sure that things like that happen. So load or performance testing can be done. It is almost always there are a couple exceptions, but it's almost always done with some form of automated system. So it will, be attached to your test environment, and it's going to try to mimic the volume and capacity of production. So it will run through a number of test scripts in rapid succession over a short period of time, and we can then measure the outcomes. So that's the final one. So from an overall perspective, you can see even with the 5 different categories of testing becomes very, very important. And in the end, we really just want to make sure that what is going to happen in our production environments and in our live environments is what we thought was going to happen, is what we designed to happen, and is what the users are expecting to happen. So testing is something that isn't a one and done. It is meant to be an ongoing activity. And we all need to recognize in healthcare, as in any other industry, there's going to be unanticipated events that do occur. We are not going to be able to catch everything. We certainly want to try. But in the event that something does happen, we want to make sure we learn from that and that we adjust our test scripts accordingly, so that over time we make sure that things like that don't happen again. So ongoing management of those test scripts is essential. We need to keep them as living, breathing documents. They should be set up in a way that they can be layered upon and that they can be utilized over time. It takes a great amount of effort to put them together, so we don't want to have to start from scratch or reinvent the wheel every time. We want to make sure that they're living and breathing and that they continue to grow with us. And we want to make sure that we review all the documents for accuracy. We want to make sure that they're remaining accurate, that they have expectations that we've put in place, and that they're being updated appropriately. So if you've learned something along the way or want to clarify something or add in a bit more detail, you want to make sure you do that. So again, they're going to keep growing over time. They're incredibly important. And the various types of testing is something that we want to encourage and learn to love. So it sometimes takes a lot of time. It can sometimes be frustrating, but it is something that is unbelievably important and that we should all sort of strive to be good at. So I'll leave you with one last little quote. Each of my blog posts, I end with a quote. Hopefully that relates a little bit to the topic. And the one that I want to leave you with today is testing leads to failure, and failure leads to understanding. So we need to learn from our mistakes by doing these in the testing environment. Hopefully that's where we're learning them from. And we'll continue to move forward and continue to incorporate more IT into our space. So thank you for watching, and if you like what you see, feel free to subscribe to the channel, and if you have some more topics you want me to talk about, add them in the comments below. All right, see you next time.